Okay, so in this problem we're going to do an assignment problem using the Hungarian algorithm. So we're given this cost matrix for this assignment problem, and we would like to circle 3 boxes, one in each row in each column, such that the total in the boxes circled is minimized. So to do this, we're going to use the Hungarian algorithm. So we're going to take this cost matrix and transform it into an equivalent cost matrix. So we notice that what we can do is we can subtract any number we want from a row, and it will be an equivalent problem, and we can subtract any number we want from an entire column, and it will be an equivalent problem. So I will subtract the minimum from each row. So from the first row I'll subtract 6 from every entry, so I'll get a 0 here, a 18 here, and a 1. From the second row I'll subtract 4 from every entry, so I'll get a 0 here, a 9 here, and a 1 here, 9 here. And from the third row I'll subtract a 9 from every entry, so I'll get a 16 here, a 7 here, and a 0 here. And then I'll notice that, okay, there's a 0 in every row, but there's not yet a 0 in every column. So let me subtract 7 from the second column. So let me turn this into another equivalent cost matrix by leaving these two columns the same, columns 1 and 3, but subtracting 7 from every entry in the second column. So I'll get an 11 here, a 2 here, and a 0 here. Okay, so now we're at the point where there is a 0 in every row and in every column, but I still can't circle 3 zeros such that there's 1 in each row and each column. So what I want to do is I want to create more zeros in this table. And to do that, let me try to cover up all my zeros so that I know which boxes I'm looking for. And now in the remaining boxes, the minimum entry is 1 here. So what I want to do is I want to convert these 1s into zeros without affecting any of these 0 entries. So what I'm going to do is I'm going to subtract 1 from every entry in the table, and then I'm going to add 1 back in to column 1 and to row 3. And so if I do that, what I get is that if I'm subtracting 1 from every element of the table, and then I'm adding 1 back into column 1 and row 3, then these entries which are not crossed off are going to be reduced by 1. The entries which are crossed off once are going to stay the same because I've subtracted 1 and then added 1 back in. And this one entry that's been crossed off twice is going to be increased by 1. So my new equivalent table is going to be 0, 0, 17. And then all of these 4 entries are going to be reduced by 1, so I think I get here a 10, 0, 0, 1, and these zeros stay the same. And now at this point I can find 3 zeros, 1 in each row and each column, and so definitely the weight is minimized at this point. And since I've only done equivalent transformations, I know that, for example, this is an optimal assignment in this problem.